today's lecture, we're going to talk about product rules and power rules of exponents. We understand what exponent is, right? Exponent is when you have a to the n exponents, right? Unknown number on the power, right? Then, in order to understand this topic, here is 4 rules that you need to remember. 3 start because it's important to remember. The first one, when you have a same base with different exponents, you can combine them as adding. So multiplication of the same base with different exponent is same as adding the exponents. If you have a double exponent, I call this double because you have 2 exponents, right? That's same as multiplying that exponent. If you have a times b to m's exponents, you should be able to distribute this exponent long as if it's a multiplication or divisions. In other words, if you have addition subtractions, you cannot distribute your exponent. That's very important, and I see many people make mistake when you have addition subtractions. So only time you can distribute your exponent is when you have multiplications and divisions. So it's important, very important to remember these rules. Using those rules, let's see if we can solve example 1, simplifying. So this one, 2 cubed plus 2 to the 4th, this means you have 3 2's plus 4 2's. Where, using your rules, this is going to be same as cube plus 4, which is going to be 2 to the 7 exponents. That's 128. Let's look at the next one. So using the rules, if it's all same base, this is m, multiplication, that's same as adding the exponents, right? So this is going to be same as 4 plus 3 plus 5. So that gives you 9 and 12. What about the next one? You have negative numbers, but then you have a parentheses here, right? Parentheses, it means you're going to make that negative 4 to the 7 exponents. This is going to be negative 4 to the second exponent. So this means you're going to have negative 4 to the 7 plus 2 exponents, which is 9's exponent. Nine is odd numbers. If you multiply the same number odd, your negative is going to be carry over. You cannot get rid of negative when you're multiplying the same number, odd numbers of time. And if you want to, you can just leave it as 4 to the 9 exponents, or if you have a calculator, input 4 to the 9 exponents, you end up getting 262,144. So you can leave your solutions as that or this. The next problem, this is all multiplications, even though we have our parentheses. So if we open the parentheses, let's see what happened. We have 2 times x cubed times 3 times x to the 7th, where we should be able to multiply 2 times 3 first and x cubed times x to the 7th, because multiplication order not matter, right? So if we combine the like terms to multiply, 2 times 3 is 6, and x cubed times x to the 7 will be same as adding 3 and 7, which is going to be 10. What about example 2? Example 2, we're still simplifying. We're going to see if we can apply the rules of exponents. If we have a double exponent, don't forget it's same as we're multiplying that exponent. So multiplications, which gives you 15. If you have a calculator, 2 to the 15 exponent is 32,768. If you don't have a calculator and if it's not simple numbers to multiply, then you can just leave as 2 to the 15 exponents. Because it says simplified, right? Not finding a solutions. So next one, we have 2 times x to the square. So here we have a 2 factor, 4 and x. And if we have exponent with multiplication, remember we can distribute exponents. So that's the same thing, distributing to each factor. That you get 4 squared, that's easy enough, which is going to be 16x squared. The next one, same thing. How many factor you have inside parentheses? That's important to know so that you know how many times you need to distribute 4's powers. So look like you have to distribute 4 to 2, to m, and p. So you need to distribute 4 3 times. So you get 2 to the 4th exponent, m squared to the 4th, which is same as the multiplications. So it will be 8, and p cubed to the 4th exponent, so you multiply, that gives you 12. 2 to the 4th exponents, that's going to be 16. What about next one, D? You have negative 5 to the 6th exponents to the cube. So here, you have to be careful how many times you're distributing cube. This one, you need to distribute cube 2 times. Why? Because you have to distribute 1 times to the signs, and then you need to distribute second time to the number 5. 5 to the 6th, right? So this, you're going to get negative 1, you're going to cube, right? And then 5 to the 6th exponents to the cube. When you cube negative 1, it will be still negative 1. And 5 to the 6th cube, you're going to multiply it, so it will be 18. Which, this is multiplications, so it gives you negative 5 to the 18 exponents. Example 3, we're still simplifying using those rules. So we said that we can distribute exponent when it's multiplication and division. So this one you can distribute exponents to the numerator and denominator, which you get 2 to the 5th exponent is 32. 3 to the 5th exponent is 243. The next one, we should be able to distribute square times 2 cube. And because this multiplications, you should be able to do 2 square times 2 cube on the numerator and 3 square on the denominator. So on the numerator will be 2 to the 5th exponents, right? Because same base multiplication, add the numerator, denominator will be 3 squared. That's simple multiplication. So 2 to the 5th exponent, we just did that, which is 32. 3 squared is going to be 9. Let's look at the next one. We can distribute exponents and open the parenthesis, right? So it'll be 5 cubed times x cubed and times 5 to the 4th, just distributing, right? And x to the 4th. And multiplication order is not matter, so let's put the like terms together. So then you can do multiplication by like terms, which is going to be adding the exponents. So it will be 5 to the 7 exponents and x to the 7 exponents. Let's look at the last one from this section. So you're going to first open the parentheses and then combine the like base, right? So when we're distributing this, you're going to distribute square to the negative first. That will become positive. And then, so I don't really need to write anything down on that. And when I distribute square to the x, I get x to the 6. And when I distribute square to the y, I will get y squared. And then right here is times. And then let's distribute 3 to the negative. That's going to be negative. Right? And then I'm going to distribute 3 to the x. That gives me x to the 15. Distribute 3 to the y. I get y to the 12. And this is all multiplication, don't forget that. So I have only one negative, so my solution will be negative. And let's combine the like base. So x to the 6 and x to the 15 will be multiplied. So that will be same as adding the exponents. So that makes it 21. Let's do that with black. And then let's do y squared with y to the 12 exponents. Y to the 14 is what I'm going to get. And I know I'm done because I cannot simplify it any further. I have 1 of x, 1 of y, and all positive exponents.